Hello, I'm Sarah Barth, Executive Director of Semper Virens Fund. Welcome to another in our monthly webinar series, Under the Redwoods, where we explore the beauty, history, science, and benefits of redwood forests. We want to thank Scharf Investments, who's been our longtime sponsor of this webinar series, for their amazing support for this effort. Since the CZU wildfire 5 years ago, there's been a lot of progress in how we address fire in the management of our forests. And among the most critical tools that we've always known about but are increasingly pushing to use is prescribed fire and prescribed burns, which is an especially effective tool for protecting redwood forests and other forests from future catastrophic wildfires, and also an effective tool at helping to protect surrounding communities that are adjacent or amongst these forests. Understanding this tool and its effects has had its challenges over the decades, but a new generation of research is underscoring just how important it is. It's why I'm so pleased to have with us today Dr. Mike Jones. He has a PhD from the SUNY College of Environmental Science and Forestry, and Dr. Jones works for the University of California's Cooperative Extension Program, specializing in forestry and wildfire risk reduction efforts. So he is on point to talk as we mark, I don't know that we're celebrating the 5th anniversary, but marking the 5th anniversary of the CZU wildfire. So welcome, Mike. We are delighted to have you.
Yeah, thank you. Good afternoon, and thank you for having me. If we're ready, I'll share my screen and start the conversation. Yeah, so thank you, everyone. I appreciate the opportunity to speak with Semper Virens Fund in their webinar series, which is a really great great thing. And so what I'm really excited about, interested in talking with you and really hearing feedback from the community is some of the work that I'm doing in Northern California with prescribed fire in redwood stewardship. And really specifically, I'll be focusing on some of the work we're doing in managed redwood stands. So thinking about how do we manage redwood stands when we have multiple goals and objectives, and what role does using prescribed fire play in those kinds of processes. So I'm not, I know you've had lots of webinars from other very interesting and qualified people, so I'm not going to spend any time really going over fire ecology in the redwoods. Just to summarize, to say, we know redwoods are fire adapted species. They are disturbance dependent ecosystems. And so fire is a really important stewardship tool for this space, not only for thinking about community risk and safety and fuels reduction and wildfire risk, but from an ecological perspective as well. So, thinking about how we can use fire to achieve multiple goals and objectives is really kind of an important and interesting space right now. So as Sarah mentioned, Michael Jones, I'm an extension forester, also a registered professional forester. I officially cover Mendocino Lake and Sonoma counties, but you've heard from my colleague Brian Woodward before, so there's only 3 of us in the redwoods, so we kind of collaborate quite a bit. I also work quite extensively in forest health and disturbance ecology in oak woodlands. Today we're going to talk about redwoods. All right, so I'm just going to introduce a couple research projects and spend a little bit more time on one project because it's really interesting. We're right in the middle of it, and we just completed the burns last fall. So lots of interesting things we're observing, and it's just kind of a really impressive study that I'm really proud to be a part of. But I'm going to just work through kind of the history of this research. Before I do that, I just want to acknowledge that this is. It takes a lot of people to make this happen, right? It's not something that I just go out in the woods and can write a paper and say, I did all this work by myself. It takes a huge amount of effort and collaboration to kind of even put fire in the ground to make the research happen, and really can't express how much I appreciate the support of state agencies, research institutions, and local agencies in helping us to conduct this research. And of course, the funding, right? CAL FIRE's Forest Health Research Grant has been a big source of support for this research as well. So just to give a little bit of context, again, this research is primarily happening on the Jackson Demonstration State Forest, which is an approximately 50,000 acre state forest in Mendocino County near Fort Bragg. If you're all familiar with it, I highly recommend you check it out if you've never been there. It's a pretty amazing spot. But as you can imagine with that size, and here's a map, the kind of, it's not the greatest color differentiation, but kind of the light green areas are the perimeter of the forest. So as you can see, there's quite a huge gradient going from west to east. And as you can imagine, the forest types are highly diverse within this ownership as well. So it makes it it's just a demonstration for us. So it makes a great living laboratory, and the forest has been incredibly supportive and lets me kind of do whatever crazy thing I want to do in this space to kind of explore disturbance ecology. So the first project that really started with was prescribed burn in a recent timber harvest. The idea being, thinking about what role does fire have after, timber management. Usually with current forest practice rules and the way we manage for timber, pile burning is a really important tool for dealing with slash and biomass created from the harvest operation, as well as managing fuels and fire risk. But the idea here was like, let's put broadcast fire back into the system and look how the system responds. How does the stand respond? But, having that slash and having those recent stumps and resprouts and all those things that happen after harvest within a year or two, how does the system respond? And it's just been kind of a really great learning tool that's helped set us up to kind of explore and deepen our research and our understanding and kind of, questions that we can ask based on how this system responds. So we burned it and we've been tracking it. And I know this is a lot here, but the point is that we've been tracking it through time, surveying our plots, capturing photo points, looking at how after the harvest, then the burn, and then how the system responds after the burn. And that's just given us a wealth of information and data that has really, like I said, informed the rest of the research that I'm going to be talking about and into the future. So it was a really great pilot project. And again, we kind of went big. We went over 50 acres really quickly. This is the first prescribed fire that Jackson Forest had done in quite a while. Big support from CAL FIRE in the unit and the region. And so it was a pretty big kind of accomplishment to even just start this process on state land. Yeah, I'll focus and I guess spend a little bit more time on this project because I'm really excited and proud of this research, and we're just learning so much, and it's just been such an amazing effort. So this is a research project that is a collaboration between myself, Cal Poly Humboldt with Pascal Barrel, who you all might recognize as a really significant silviculturalist in the Redwoods, Rob York out of UC Berkeley, and then of course support from CAL FIRE. And really kind of where this project came out of was the idea of, we're thinking about managing for multiple goals and objectives. And if you're managing for timber, you inevitably, after you enter a stand, you're going to create a new cohort, right? You're going to recruit a new and you might also want to think about fire risk, but really what happens when we do fuels mitigation work oftentimes is an understory thin. And that means removing small diameter trees, which might be that new cohort that you established on that last harvest or that last entry. So the idea here was thinking about how can we manage for both these goals and objectives? What are the trade-offs and the efficacies of different types of fuels treatments? So what we did was we set up a study where we had 6 treatments replicated across the forest 6 times. We have a control, which means, we leave the stand alone, do nothing. We did a lop and scatter, which if you're familiar with is a standard kind of cut biomass down and lop it up so it sits down on the ground. We did a lop and scatter followed by a prescribed burn. We did mastication, which is using heavy equipment to chip up and mulch material. And then we did a mastication bus burn. And then we just did a burn with no pre-mechanical treatment or hand treatment. We just burned the stand as the structure looked like. Established a series of plots, right? So there's a lot of data collection happening in this process, looking at the trees, structure and composition, forest health issues or damages that might make trees more vulnerable to fire, looking at ground cover and the fuels in that space. So we're tracking these changes through time with each different kind of disturbance we introduce in the stand. And if you can see in this plot map, we grouped our burn units together. We lost some of the randomization that we look for in research, but we really, operationally to make prescribed fire happen on this scale, which we burned about 500 acres, you have to kind of group units together, and it makes it a lot easier to accomplish your goals and objectives. But as also these treatments were about 10 acres each. So it was a pretty big study. So just to give you a sense, this is what the stand looks like before we did any treatment, right? This is these stands that we set up the study and were 7 to 10 years old since the last harvest. So in that time, quite a bit of resprouting and regeneration in the conifers and the hardwoods. And so it's a pretty dense understory. With the prescription that we set up, which was really interesting and kind of challenging from an operational implementation perspective, was, we want to do fuels reduction and mitigate wildfire risk. But we also maintain some of that regeneration we established, as I mentioned. So how do we merge those together? And what we ended up doing was really thinking about it thinning from below, which is kind of a common practice for thinking about building shaded fuel breaks, or even if you some of the cost share funding that's available for landowners to do stewardship, the forestry improvement program through NRCS and their EQIP. That's kind of a standard procedure, is to thin the small diameter trees out. So we did that, a thin below, remove small diameter trees, but we retained some of that regeneration to maintain a 20-foot spacing, because again, we're managing for timber. But we wanted to pull fuels away from our reserve or our kept trees, because we don't want to pile a bunch of slash or biomass against the base of the tree when we burn. That's not ideal. And we also want to maintain and manage that really deep fuel bed. We want to kind of keep it within prescription, within the forest practice rules, and also what a lot of landowners are doing with their own fuels reduction work. So it's an interesting mix of kind of goals and objectives in the space, and took some time to really work out and implement. So here's just an example of what lop and scatter looks like. As you can imagine, it was mostly tan oak, small Doug firs, and redwoods, but it was dense, right? Continuous mat of at least 18-inch thick, lopped, small stem conifers and hardwoods. Here's mastication. That some of those pictures were mastication equipment, basically just a big disc on an excavator, and just grinds, just like a chipper. It's pretty impressive to watch. Just grinds that material down and kind of pulverize it into chip material of different sizes, and even large diameter material that gets kind of pushed on the ground. But if you remember back to that pre-treatment photo, these stands look very different following treatment, right? We went from kind of, a understory with not a lot of a view shed to kind of opening it up, and now there's quite a bit of light coming down to the forest floor, and you can see through these treated areas. So it was a significant change in the forest structure. An interesting part that we added, because it was a collaborative effort, is Jackson Demonstration State Forest has a wildlife biologist, and he was really interested to see how wildlife responded to these disturbance events. And so he put in a couple of autonomous recording units, one for birds and one for bats, as well as a trail camera to capture the wildlife use of these disturbed areas. One in just mastication, one in mastication and burn, and then one set up in the no treatment across all 6 study sites. I won't go much into this, but he has something like 30 gigabytes of data that he's currently processing. It's pretty incredible how much data they've collected, but they're finding really amazing and potentially maybe not new, but never really captured on camera or audio before, observations of wildlife. For example, the Humboldt flying squirrel, which they knew was on Jackson, but this is the first time they've ever really captured on camera. We've seen the flying squirrel in several of our sites. But essentially what happens is, just like humans, wildlife love really open forest. It's not hard to navigate. And so we see these sites becoming significant wildlife corridors, and capturing really fun stuff like predation events and stalking events, like mountain lions stalking deer or bobcats capturing squirrels and stuff. So it's been a really amazing thing to see the wildlife responding and changing after these different disturbances. So then we burned. So we did all the treatments over a year or two. The mechanical treatments took some time, quite a lot of area that we're treating. And then we picked a burn window. We burned last fall in late October. We had pretty mature fuels, which was part of the goal, was to make sure we had cured fuels, but they weren't too old. And for those of you who are kind of following or interested in prescribed fire and some of the mechanics and the prescriptions, we really hit, which is surprising to me. We're burning under fairly cool and wet and kind of more moist conditions, which is, the redwoods are really well adapted to fire. So I guess it's not that surprising overall, but we had really good fire effects and what I would consider to be the low end of our prescription window, meaning it was on the cooler side, a little bit higher relative humidity. And of course we were burning with relatively no winds. So it was really interesting fire behavior to observe. Of course, we're on CAL FIRE on state land. So CAL FIRE was in charge of firing operations, but we really worked closely with their teams to make sure that we did kind of a prescribed burn prescription using dots and strips, if you're familiar with those terms, but kind of burning really slowly, not building a lot of head fire, trying to kind of consume fuels at an even rate, not burning too hot, not going too quickly. And then within each project site, we had a series of fire effects monitoring research team so that as we were burning, folks were collecting data in that time and moment, which is really cool to see, like kind of capturing weather data and tying it specifically to fire behavior observations, and then coordinating that with the post-burn resurvey of the plots to really have a nice picture of fire severity in those fire effects. And then we also have the opportunity to fly drones. We're still processing these data. It's hard to capture a lot of information with cameras when you're still in a closed canopy, but we did some thermal imaging, and I think we have some interesting things coming out of that, hopefully. So burning, this was really fun. I mean, we burned 500 acres over 3 days. So it was pretty intense and impressive in Denver. So you're just some pictures of fire as it was happening. This is the fire effects of lop and scatter. I mean, not surprising. I think, you know, we've all kind of enough experience at this point and have seen how wildfire burns through lop and scatter, but it's a lot of fuel. It's basically just, you know, an 18-inch thick layer of a campfire continuously built across your forest floor. So lop and scatter burns well and completely and uniformly and fairly hot. But I like, you know, these, so that was captured during firing operations. And then these series of photos, the ones on the left are immediately after the burn or a couple days later. And then the one on the right is usually a couple months afterwards. So I like the fire effects in lop and scatter. What we saw happening during the burn is the exact same outcomes that we saw. There was no new mortality, no new issues appearing months later. So lop and scatter, we understand we can have a pretty good prediction of what that is going to result in when we burn. Mastication was an interesting and a different experience. And I think a lot of, you know, this is new for the Redwoods. They've been certainly using mastication quite a bit in the Sierras and other ecosystems. But for us, mastication is relatively, you know, not widely used in the Redwood ecosystems. And so we were really interested to see how the two burning masticated fuels. If you can kind of tell, very different fire behavior, low flame lengths, low rates of spread. So, you know, interesting fire behavior, as you can imagine, because it's more dense, there's more moisture, it kind of just doesn't have as much oxygen. And so you have a slower rates of combustion. But what happens with mastication is at that slow rate of spread, you get a higher or longer residence time, which is kind of the amount of heat that the soil or the roots or the trees are exposed to. So right after the burn, we saw really interesting fire effects that looked almost less severe, you know, just observationally than the lop and scatter. But coming back several months later, we're seeing tons of pockets of mortality or top kill, right? I mean, you can't really, it's hard to kill a redwood or a tan oak, but we're seeing top kill and lots of resprouting or epicormic sprouting in smaller diameter trees. Because we think the residence time was so high in the mastication that it just cooked the root crown or the roots of these trees and killed more trees than we had hoped or expected. You know, that's not necessarily a bad thing. It's just an interesting outcome and certainly would affect, you know, your decision on using mastication as a stewardship tool, depending on your goals and objectives. And then lastly, the controls, right? No thinning. You saw that dense kind of forest structure with at least a 2-story, you know, dominant canopy with a mid-understory. And with, you know, the way when the burn window we were burning and the conditions we were burning, sometimes we had a really hard time to get the controls to actually catch on fire. It was really interesting talking with CAL FIRE, who they're always kind of suggesting that they were really concerned about burning the controls. They thought it turned into a wildfire. And every morning we're like, during the briefing, I was like, we're going to have a hard time burning the controls. And they were like, no, it's going to be intense in a wildfire. And I was like, we're not going to get them to burn. And every day, same, they were like, wow, it was so hard to burn the controls. So I was like, yeah, I mean, that's something to really think about, that we didn't manage the vegetation at all. And it created the kinds of conditions where it was actually really hard to use prescribed fire in some instances. But we see really interesting kind of fire effects in the controls, and I'm really excited to keep exploring that. And I think I like the outcome a lot in these systems of not doing mechanical treatment ahead of time and just burning initially as your first step in your stewardship practice. Okay, so that's that project. If you all are interested, I host tours of these research sites all the time. So if you ever get up to Mendocino, let me know, or ask to be on my listserv, because I'm taking tours out and we're looking at these sites in person. And it's really fun to have those conversations and look at fire effects. And just to conclude on this project, right, we just finished burning. We're still collecting data, have different interests at different stages of time. So immediately following, looking at survival, top kill mortality. What kind of pest and disease issues do we have? Been seeing lots of redwood bark beetle and other insects show up in fire damaged redwoods, Doug firs, and the oaks, the tan oaks. But how does the vegetation respond? What kind of understory vegetation, annual or herbaceous growth do we get? How do the soils respond? We're looking at all these things. 5 years off, we're looking at how does fuel loading change because of the way we affected the stand structure composition. How does that change? And then long-term, thinking about the fact that this was a stand that we're managing for timber, what effect did we have on the timber resources? Did we kill that young cohort of trees and we had to start over? Did we damage larger trees like you guys have been seeing in the CZU with some of these wet rots and things damaging the timber value? What kind of long-term consequences are there potentially, or impacts, I guess not necessarily a consequence, but an impact from using prescribed fire when you're managing for timber? So again, it's a really interesting project, and I'm excited about the long-term implications. Following that fuels mitigation study is just something I'm really, really excited about, and we're calling this a pyrosilviculture research project. Certainly can't take credit for that term. It really comes from my colleague, Rob York, out of UC Berkeley, who's a forest manager at Blodgett in Georgetown. Blodgett is a UC Berkeley forest. And I'm just taking his research, his ideas, and implementing in the Redwoods. And the idea here is typical models of using prescribed fire, just like we did with the fuels reduction, was you do the fuels thinning, the reduction, and then you introduce prescribed fire. And in this context, we're flipping that on its head. We're saying, let's start with fire in the stand before we've done anything else. We'll burn it. We'll use the fire effects, the fire severity damage as a metric to help with our marking guidelines for the timber harvest. So this is on the context of conducting a timber operation. And the idea behind this is, it's pretty large, but it's to be succinct as I can, is instead of letting foresters and folks kind of think about and try to decide what a resilient forest structure looks like, we're going to reintroduce disturbance and allow the fire to kind of select and cull out the weakened trees and then harvest those trees that are damaged, so that as we think about long-term goals and objectives and restoration goals, that we build resilience back into that stand by letting the fire remove under controlled conditions without doing extensive damage. Let the fire decide which trees we remove to help build that resilience and health back. So I'm really excited. We're just collecting data on that right now. And kind of some of the questions and hypotheses we're coming up with, just like I mentioned, was if it's the initial treatment, how does it influence, long-term forest structure composition? How does burning before you do a harvest, or we're going to burn at different periods and different parts of the stand, how does that affect fuel loading long-term and fire behavior potentially? And then a really interesting thing that's come up since we've really introduced this idea is, how do you do this under the forest practice rules? We submitted this project as a potential THP, and the forest practice rules were, basically said, fire is not recognized as a silvicultural tool under the forest practice rules. And so they were kind of like, what are you guys doing? And so it's been an interesting conversation to kind of figure out how we can make this happen and what kind of changes we need to see in the forest practice rules to allow fire to be something that we can potentially use as a silvicultural tool into the future. So this is a really exciting project, lots of interesting potential out of here, and lots of goals and objectives and collaboration that we're building as we move forward. This is not necessarily related to burning itself, but the common way that we measure fuels in redwood forest and the ecosystem, really, to establish kind of that fuel loading and have we achieved our goals and objectives, or do long-term monitoring after different types of stewardship practices, is to use, and specifically think about fire, is use Brown's transects, which are this fairly magical tool of you lay out a tape and do a transect and measure sticks of different sizes and do some calculations, and it turns into an estimate for tons per acre of fuel loading. It's pretty amazing. But it's rather kind of labor intensive, takes a lot of training. And so we have a new research project where we're going to try to build what's called a photo loading model. And essentially, this was developed by the Forest Service. They've implemented in a different ecosystems, particularly in the Rocky Mountains and some of those other places. But basically, the idea is that they develop a photo series, a photo guide, with a 1 meter grid as your reference, and they destructively sample all the vegetation in these 1 meter grids, pre-calculate fuel loading, so that as you go out in the woods and you look around, you can use this reference guide, this photo loading guide, and look at what photo aligns with kind of my current forest structure. What does it look like in the picture versus reality? And then it has a pre-calculated tons per acre of fuel loading across fuel size classes, and makes it way easier for estimating fuel loading so that you can do real quick and rapid monitoring through time without investing a lot of time and money and effort into this. So we're hoping this becomes a really widely available tool that helps us improve our monitoring to determine if we've achieved our goals and objectives, and to really understand kind of what's happening after fires or after different disturbances. So that's a new project that we're working on. It's very exciting. And then lastly, I just want to mention, this is an ecosystem that's tangential to the redwoods in my neck of the woods. We're looking at returning disturbance to the pygmy ecosystem. And in pygmy, is kind of a very broad term, but these forests that are stunted, that grow on nutrient-poor soils, and these interesting steppes, the marine terraces in Mendocino County, and have unique species. They're very disturbance-dependent ecosystems. They have stratinous species and resprouting species, but disturbance has been removed. Primarily fire has been quite a long time. There's lots of invasive species. They're very unhealthy. And so we're thinking about how do we put fire back in these ecosystems? And because the soils are so unique and interesting, this has turned into a really amazing collaborative research project where we have researchers from UC Berkeley, UC Davis, Colorado State, Yale, Stanford, and I probably even forgot some other places. Cal Fire is certainly involved, and as well as my side from UC. And we're just looking at collecting as much data as we can before we, burn these in a prescribed burn and look at how the system responds. So this is a really exciting project. Not necessarily in the redwoods, but we're on the edge of redwoods. So there'll be interesting things to look at about how the relationships, how these different ecosystems interact, or how fire kind of burns across these different vegetation types and how the systems respond. So this is a really exciting project that we're just working through as well. And also when we proposed it as a project, a lot of people scratched their head because pygmy in Mendocino County is considered a sensitive habitat, and burning it, not necessarily. While long-term is a really important stewardship tool, short-term, it can be a disturbance that's rather destructive. And so people are like, how is this restoration? And so it's kind of been an interesting conversation about what this looks like and why we're doing it. That is my quick run through of my research. I hope we have time for questions. I really appreciate you giving me your time, and I know they will probably post my contact info, but if you are interested, feel free to reach out to me. Here's my email contact on this slide. And I'd be happy to add you to a listserv where I advertise for workshops and events or just general information. But yeah, thank you. And ready for questions. I see we have a couple. So thanks, y'all.
Thank you, Mike. That was great. Can you hear me okay?
Yep.
I have a few questions. I'll start off. Webinar facilitator prerogative, and then we'll turn to the audience. Starting with your first study, first of all, thank you. Really interesting and really applied, which is what we're all about as folks who have to, on a day-to-day basis, make choices about what to do with the lands that we're responsible for. So thinking about your first study, and the answer may be that it's too soon to tell, but I'm wondering if there's some broad takeaways you can signal to us about the different tools that you were using, and you sort of started to hint at it, but which of the approaches seem like they might be most useful for an organization like ours that's really focused on restoration forestry and avoiding catastrophic wildfire, and is maybe a little less focused than, say, a timber company might be on commercial production?
Yeah, that's a great question. And if I had the wherewithal, I'd make shirts or hats or something that said, it depends, right?
Yeah.
We have a toolbox full of our management tools, and what tools we use, how we use them, totally depend on short and long-term goals and objectives. So that's a great question that I'm not going to have like a broad general answer for.
Yeah.
I will say that from my perspective, I've burned, almost 1,000 acres of redwoods now, and I'm beginning to like when it can be done safely and done well is to burn without doing any initial treatment. Using fire as your first step in the stewardship process, and thinking about what fire return intervals look like in that space, how we mitigate risk because we're going to kill things, and what do we do with that biomass. I really like the way the redwoods burn doing that. That's not always the best approach in other systems, right? I'd probably not recommend that in a thick ponderosa pine forest with tons of white fir, because that's going to be a really big fire. But in our system, I'm really interested and that's why the pyrosilvicultural THP is interesting to me, is that we're kind of replicating that and really going to see how the system responds.
Yeah, and one of the things, I'm going to say some things about it, but I'm hoping you can expand on it for this audience to understand and think about, there's what might be ideal that we could do. And maybe the answer is that you do mastication first and then burning. Or one of the different iterations that you've suggested. There's what is done in an academic research context across, as you said, 500 acres was a really large project. And then there's the reality that if you are state parks and you're managing big basin that is 17,000 acres, or I mentioned Tony Coast Areas National Monument, almost 6,000 acres, or Semper Virens, which owns and manages San Vicente Redwoods, which is almost 9,000 acres, then doing that kind of high level intense treatment across 500 acres a year probably isn't going to be quick enough. And so as we're thinking about scaling up to get treatments across the scale of where work may need to be done, I wonder how that plays into some of your thinking. In that context, I would imagine hearing that prescribed fire on its own is the best treatment might be best for us because it's the most feasible and cost effective. I don't know if you have any observations or thoughts about that.
That's a great point. That's a big question too. I would say that yes, building a big burn box, big prescribed burn unit, and then just doing like shaded field breaks to improve your control lines and not touching the interior is definitely like a way more cost-effective tool than doing per acre treatments, because it can, as you all know, it gets really expensive very quickly.
Yeah,
so when that's doable, I think that is a very viable tool to kind of just use fire initially. But it just so much depends on what the structure or kind of the composition and structure of the forest looks like, and what kind of risks you're willing to accept, what kind of damage you're willing to accept. If you do have a hot spot and it does crown up and kill some big trees, is that acceptable? It burns you into a goose pen, right? So there's all these things you have to take into consideration before doing that. But yeah, fire by itself, when done safely and kind of our due diligence, can scale quickly. And one other thing I'll say about these other treatments is, lop and scatter mastication have been really big tools for thinking about fuels reduction and fire risk. And they work well from a suppression perspective, where they can change fire behavior, for example, to take it from like a crowning fire to the ground, which is very common in the Sierras, but it still requires suppression, because if you're not removing the amount of biomass in the system, if you're just redistributing it from ladder fuels and aerial fuels to just surface fuels, you haven't reduced the overall tonnage, the fire is still going to burn really, really hot and do a lot of damage. So part of the thinking about how we do stewardship, no matter which route we take or which tools we use, is you have to reduce that initial biomass loading to reduce, potential fire effects in a wildfire. So that's kind of a big takeaway, is it doesn't matter which path you go. If you're gonna do lop and scatter, you either need to pull that material out, or you don't lop and scatter, you lop it and pile it and burn it, or you lop it and pull it out and chip it, whatever. But if you leave it there, if it burns real quickly after wildfire, you're gonna see significant effects and damage to your stand. So
yeah, and to some degree, I know we've had other wildfire experts come on, especially right after the CZU wildfires, said, well, that may have been kind of like an initial treatment for the whole region, but it doesn't last long. And if you don't keep up the follow-up treatments, you're maybe not right back where you started, but it really, I think that I mentioned at the outset of the webinar that wildfire was such a huge wake-up call for us and others in the region. And in part, it's just the volume and scale of treatment that's going to need to be ongoing in these forests for a long time to get them sort of back to a more steady state where catastrophic fires aren't as big of a threat.
Right. And yeah, the maintenance point is absolutely crucial, right? It's not a one and done fire. You don't just burn once and you're fix all your problems. Now you've started a really intensive lifelong stewardship regime that you need to continually think about. And that's the challenge from a funding mechanism, because funding sources right now fund that initial work, and they're not really geared towards long-term maintenance of those projects. So it's a challenge right now.
Yeah. Well, maybe that's a good question to pivot to some of the policy issues that you just touched on. And I realize you're not a policy expert, but for sure, one of the things we've focused on organizationally is advocating for more state and federal funding to support this kind of work. And I'm curious, from what you've observed or experienced in your own research efforts, what have been some of the biggest barriers to doing more prescribed burns, more of these kinds of fuel treatments? You mentioned the forest practices as something that didn't really know how to handle what you were working on in one particular instance, but what else have you experienced, and what are some of the things that you think are the barriers to scaling up this work to the degree it's going to have to?
Yeah, that's a great question and deserved its own webinar, honestly. And I'll try to keep this brief, and I can't claim a lot of the credit for the work that's happening, but within UC Cooperative Extension, or our larger umbrella, the Ag and Ag, my colleagues, Lenya Quinn Davidson and Jeff Stackhouse, have been really the champions of prescribed fire, in particular prescribed burn associations and community burning. And they have been really driving conversations and action around policy change that really help to address the big concerns. And there's so many challenges that we could probably just come up list and list and list. But big ones are like liability and smoke and all these things that people are concerned about, the risk of fire escaping, and those challenges. And my colleagues have been really active in this space to change state legislation and language around simple liability, gross negligence, creating California certified burn bosses. So that's another limitation, is professional capacity. And creating a liability pool insurance funded by the state to allow fire practitioners to burn with protection should there be an accident. So, and these changes are ongoing and always, we're adjusting and regrouping and pushing forward. But there's a lot in that space, and scaling up, not just perceptions from the community and people concerned about using fire as a tool, but also the resources in those spaces, access, and all these things that come with thinking about how do you burn a fire, build a fire, start a fire in a controlled manner at scale. It's a big question. And so certainly within the forest practice rules, having them become more current to the use of fire at different points of the stewardship process or the timber management process is going to be big too, to expand capacity for a lot of the work that happens under the framework of the forest practice rules. And then lastly, a big entity in this space is CAL FIRE. And so part of it is having CAL FIRE at the table and having these conversations and really building confidence and trust that we can expand this tool and help also educate them on stewardship, right? They're very much geared towards suppression. And so part of it is kind of, working with the great capacity they already have and just building that out and kind of building collaboration. So that's just like
shift.
Yeah, it's
part.
a shift.
Everybody's part.
Yeah, that's just skipping across the surface, but that's a big challenge right now, is prescribed fire and build. And I think we have good momentum. The prescribed burn association stuff and things that are happening right now means that we've made a lot of progress in the last couple of years. It's pretty impressive.
Yeah, that's my sense as well. And we've been the beneficiaries of some of the policy ideas that your colleagues have generated that have made it easier for nonprofit entities like us to take on prescribed burning and not run the risk that the liability is going to, bankrupt my organization, which is huge. Would not be able to do some of those things without that. Well, one last question. I'm going to pivot to yet a different area for discourse, and then I'm going to open it up to ask my colleague Matt to bring us questions that you've gotten from the audience. And that touches on the issue of the timber industry, which, speaking of mind shifts, historically, Sempervirens was created to halt logging in our region, and today the remaining timber industry lands are some of the most important redwood havens in the region. The industry is a very significant and important neighbor and partner to us. So the world has changed dramatically. And as we think about supporting more burning and other kinds of risk reduction activities, I'm always curious how they're thinking about it. And they are driven, obviously, by, as they should be, by their profit motive and commercial harvesting. So I was curious to hear from your studies what kind of reaction you're getting. My impression has been in the far past that something like prescribed burning would have been anathema to the industry, because why would you ever put your most precious asset and purposely burn it? But I'm curious what kinds of shifts you're seeing in thinking, if any, and what you've learned about how some of these tools could be used on timberlands that are commercial harvest timberlands and not, nonprofit conservation lands.
Yeah. That's an interesting question. You see a really positive response from the commercial timberland owners, that they recognize that they can't just suppress fire anymore, that it's an important part of the ecosystem. And so you see them, it's an interesting cycle, right? We go back to the beginning of the timber industry in California when we first started logging redwoods. They used fire all the time, and they probably used way, way, way more than we needed to for quite a long time. And then fire suppression came around, and now they went cold turkey, and it kind of became just like you said, a bad thing from a timber management perspective. But I think we're seeing them come around. They're doing more. There's more interest from the large timber landowners and implementing prescribed burns. They're still thinking about the risk, and that's why we're studying of, how does fire damage potential future timber? And where this is really critical for me is, if you're doing even age management in the redwoods, frankly, it doesn't matter, right? If you're cutting all the trees, you can burn however you want.
Yes.
Like the trees are gone. But when we're doing uneven age, or what we call multi-age management, that's where the trick comes in, because if you're establishing multiple age classes, how do you burn without damaging each, young generation as you re-enter the system? And that's where we're seeing a lot of interest from the timber management community, if you will, of kind of how does this tool work? And that's why we're exploring with implementing at different points in the THP process to see, like, where can we really fit it in? And how does it help them achieve their goals and objectives? Like, can we use prescribed fire to trigger, for you guys down in Santa Cruz, you have really good viable seed production, like, all the time. In Mendocino County, we don't realistically, it's kind of very spotty and irregular, but we have seen after fire and smoke and heat, really viable cone crops. So can we use it to help trigger regeneration and help them meet their goals and objectives? And I think that's an interesting space for me, is merging what are arguably like very competing ideas of, managing trees, keeping them healthy and undamaged, but also returning a disturbance that could potentially damage them. Yeah, it's a little bit of a conundrum that we're really trying to figure out what it means, what fire return intervals look like, what kind of fire would they want to use if timber was a priority resource. So yeah, but we do see a positive interest at this point. Yeah,
that's great. And in our region, the lands are so interspersed, conservation lands with timberlands, that the idea that, say, Sempervirens would do a big burn on one of our properties, but the adjacent property owned by the timber company is not going to do something similar, sets up some questionable outcomes in terms of what would happen when fire naturally occurs.
Yeah.
And so I think it's really critical we be in dialogue with that community about,
because they recognize the same thing, right? They're like, oh, they're stewarding their lands and reducing fuels, and we're just kind of not using fire, and that creates this weird dynamic. They're like, is that a sustainable practice, or should we kind of expand? So yeah.
Well, thank you. Your research is really timely and applicable. So Matt, I'm going to invite you to share with us any questions you have from the audience.
Yeah, thank you, Mike. This has been really fascinating. We are obviously paying a lot of attention to forests and recovery from the CZU wildfire, but there's lots of healthy forests that also are benefiting from prescribed fire treatments. How are you seeing the difference in treatment intervals between the healthy redwoods and those that have been already subject to wildfire, maybe are flush with ceanothus and other ground cover?
Man, that's a great question. I'm gonna cop out a little bit, and well, honestly, the best example we have of how prescribed fire, a long-term history of prescribed fire, can mitigate wildfire effects is you guys in the CZU footprint in Big Basin. They have a couple sites where they've been burning a long time, just doing fire, not other types of mechanical management. And we see, and they just released a paper, we see that really modified and mitigated fire effects, and the stand looks amazing relative to its neighboring unmanaged, unburned areas. So that's one of the best examples that we have in the redwoods of like how prescribed fire and other types of stewardship tools can mitigate wildfire risk. The big challenge is that, this current, if you will, kind of fire regime that we're experiencing, this high severity, large, really intense wildfire behavior is kind of novel to the redwoods. It really started, and so we don't have enough examples yet of fires, of treatments being burned over, or of how forests recover from wildfires and how post-fire or post-disturbance stewardship affects the next burn. So we're still very early in these stages, and those are really amazing questions. But that also creates opportunity to exploring how a fire return regime or using prescribed fire fits into that long-term stewardship goal to help recover post-wildfire disturbance. So I don't have great answers, but it does. It's gonna. I know that fire is going to play a really, really important role in these kind of disturbance regimes of not only mitigating for wildfire risk, but helping systems recover. Because we can't eliminate high severity wildfire. That's actually a really important part of the ecosystem is standard replacement fire. It helps create heterogeneity. But how can we mitigate the size of those heavily disturbed areas, and how can we help them kind of be more resilient and recover quickly?
Thank you. That's really helpful because I think what gets lost sometimes is the need for the high severity fire to come through as well, the natural high severity fire. So the mix of those two things is something we have to wrestle with. We had an interesting question about, probably related to your first research project that you shared, is how you factor in weather before thinning, before burning in the different zones that you were exploring with the different techniques. Cooler weather, humid weather. How do you go about thinking about weather and how that impacts the approach?
Yeah, I knew I wanted my burn window to kind of coincide with what we kind of assume was a natural period of how do I say this? Before fire suppression, the natural fire return interval and the fire regimes, a lot of forest wildfire happened in the fall. So we really wanted to burn in the fall. It coincided with lightning strikes and dry summers and also cultural stewardship. And so we wanted to hit that window. The way we kind of collectively at large, we knew from other studies and other data, like kind of what broad ranges of temperatures and relative humidities and winds we wanted. But to get site-specific information, we put out data collection. We put out weather loggers. They're called kestrels, where they record temperature, RH, cyclically every however many, whatever your interval is, minutes, tens of minutes, every hour. And so we learned for months what our patterns in weather were and what we could expect on the site. And we also put out fuel sticks, these 10-hour fuel sticks, where you set them out, they acclimate to the environment. They're wooden dowels. They absorb moisture based on the humidity or release moisture. And you can put those out and measure them, and they tell you what your fuel moisture, your dead fuel moisture is going to be. So we can tailor kind of our burn window to what we know is happening from the weather data we're collecting on site and what we know the fuel's conditions are. We also collected fuel samples from our different treatments, and we're measuring those for moisture content to kind of help us build that window. I just knew I wanted to burn in late October. And ideally burn into a rain event, right? We know that part of the safety of prescribed fire is that we know that we have long-term control. And so really we want to kind of burn in that window where it's nice and dry. We haven't had too much moisture, but we know we got a big system coming so that things are going to burn and all that moisture is going to put out that heat. So, that's a great question. And there's lots of kind of complexity to that, but we tried to kind of think about what was in the literature and then what we knew about the sites and picking that opportunity to burn. And then really having weather station long-term data helps us determine, really importantly, like what are diurnal patterns generally, what are wind patterns, and that helps us decide kind of exactly when we start ignitions and when we need to finish by.
That is very comprehensive, your approach to factoring in weather. Thank you. We had somebody ask about burn piles and whether they noted that the lop and scatter material reminded them of fire piles for controlled burning. And wondering if you think there's any relevance to the research related to prescribed burns and to pile burning, or are they too distinct?
Yeah, that's a great question because I just keep saying that. These are awesome. You're on point. We didn't include a pile burning part to this research project because we know it works, right? The one thing I said kind of a little bit ago was that if you reduce the amount of biomass in the system with your stewardship practices, you can mitigate wildfire behavior. Like we know that works. And so we knew that if you just cut things down and pile burned it and you're removing that biomass, like you reduce the fuel loading, you've mitigated wildfire risk. So we didn't really study that question because we from long-term implementation and observational data, we knew that it was an effective treatment. That being said, there's challenges to pile burning as well. It's going to be expensive. It's labor intensive. You have these superheated piles that can potentially have impacts to soil and small like forest. So yeah, I guess I don't know if that's really an answer, but we know pile burning works. We really wanted to see what happens if you create this like really thick mat and you leave it on the forest floor, what happens in fire conditions. And so that I think we proved that, fire effects when you leave that biomass are going to be much more severe than if you remove it to begin with.
Thank you. And probably the last question here is, in terms of the after effects, forest health is probably primary for you. Were you also looking at anything with wildlife? I know that there's camera footage, but is there any follow-up research that happens specifically on inventorying wildlife, and or the effects of, you just talked about soils, under the underground networks, and how they nutrient return and things like that are impacted or improved because of prescribed?
Yeah. So with the fuels mitigation project, we're still monitoring wildlife, right? We had the camera set up right at treatment, the mechanical treatment. So we captured before and after mechanical treatment. We pulled them down, we burned, we put them back up. So we're still collecting the change in wildlife response based on each disturbance. And then now that we've finished disturbance, how do the wildlife respond? We're still capturing those data. Like I said, with some of the newer projects, we're adding in more of soil, looking at soil, especially in the pygmy system, but also other types of wildlife. Now, this study looked at megafauna, right? We were looking at the charismatic species. Now we're thinking about how do we quantify impacts? So like the herps and like what happens to salamanders and what happens to insects and what happens to small little things that may not be able to escape the burn. How do they, presumably they're adapted to fire because they're a fire adapted ecosystem, but how do they respond? So we are planning to look at all of those flora fauna responses to disturbance long-term. And we're doing this research adjacent to a really amazing long-term study at Jackson called the Casper Watershed Study. And they are also really aggressively studying hydrology and soil science. And so we're piggybacking off those data and pulling those hydrologists and soil scientists in to help us understand impacts of soil and better understand, what the impacts to the microbiome and the nutrient cycling look like. And what happens when we add all this carbon to the forest floor, right? You burn under prescribed fire conditions. It doesn't completely consume all the biomass. It leaves charcoal, burned pieces of wood. How does that change, that soil health, that understory? And then lastly, we have these cool research with flux towers, which are tall towers that sit up. They are erected above the canopy, and they have water cycle and carbon cycle monitors around them. So, we're establishing this baseline, and then as we do disturbance, we can look at how the nutrient cycling, how the water cycles and carbon cycles are affected by these disturbance activities. So we're trying to study as many elements of this as we can, and just keep building that collaboration to kind of really dive in and really explore every facet. And it's just really amazing place right now.
Mike, thank you so much. I know, I'm guessing we have additional audience questions that we didn't get to. And for the audience, if we do have questions we didn't get to, we will do our best to work with Mike to get them to you, get you the answers. I guess I want to just leave with a reflection, which is, on the one hand, I feel regularly daunted by the challenge ahead of us, just even for sempervirens and the 11,000 plus acres that we're responsible for, let alone the public lands that we've worked so hard to protect over the years and whatnot. It can feel really overwhelming. And on the other hand, I feel so heartened seeing the kind of work that you're doing, hearing about some of the policy discussions that are happening, and knowing the conversations that we're part of in the region and beyond. And so I guess I leave mostly hopeful that all of this will help these forests persist, despite some of the challenges we know are coming their way. I see you nodding your head, so I'm hoping you're saying you feel hopeful as well.
I do. I feel optimistic, and I appreciate efforts like you folks who are just really fundamental in driving these conversations and around stewardship and actually helping to make it possible to implement stewardship. You guys are really important in this space, so I appreciate your support and allowing me to share my research and future potential collaboration. So
yeah, well, thank you, and thank you to our audience. It's been a process to bring along supporters of our organization and people who just love redwoods to help them understand why sometimes sempervirens is lopping off, branches of a
Mm.
redwood, or even, mechanically thinning, i.e. logging in redwoods.
Mhm.
So I appreciate our audience for being open-minded about these things and really taking a broader view, because that's what it's going to take for these redwoods to persist. So with that, I'd say thank you, Dr. Jones, for joining us. I'm sure we will have you again. To our audience, thank you for joining us for today's webinar. If you missed part of it or you want to share it with others, it will be on our website, sempervirens.org/under-the-redwoods. If you want to watch it or share it. And we hope you will join us in August. We will be actually pivoting our webinar discussion considerably. I'm sure we'll still talk about things like fire, but we're going to be joined by a natural, an illustrator who specializes in the natural sciences, a woman named Jane Kim, who was also Sempervirens' inaugural Forest Fellow. She's at the end of her Forest Fellowship, and she's going to share with us some of her experiences, some of the art she's produced, and some of the things that she's learned. So it'll be a very different kind of discussion. But as always, the underlying theme will remain those of us who care about, are inspired by, or love redwoods. So thank you again, Mike, for joining us. Thank you to our audience. And importantly, thank you to Sharp Investments, who funds this webinar series and has been a steadfast supporter of Sempervirens. So we will see you all soon under the redwoods next month. Thank you.
Thank you.